Hi, can everyone hear me? How are we doing?
You're on the 5 gigabits, right? You're on the 5 gigabits?
I'm just on whatever. All right, can everyone hear me? Are we good to go? Somebody in the comments, just let me know if you can hear me, just because I'm using whatever mic I have because I left the good one at home. Cool beans. What up, my turnip garden? How's everybody going? So today is going to be a mix of a couple different things. We're gonna do some questions. I'm gonna do some updates. I have a whole list of questions that I've already got from the community tab on the main channel page. So I'm gonna start working through those, and then once I'm through the list, I'm gonna start taking questions from the comments, and we're gonna keep this going for a little while. I'm thinking to do probably an hour, but we might do a little more if it takes longer to get through these, because I do want to answer some of your questions. Let's start with some updates. So there's been a ton of comments asking for updates on the various different projects. So people have been asking about the styrofoam worms, the saltwater fungus, the SCOBY leather, cerebrolysine, and of course the lactose. So I think I'm gonna work in reverse order. So people have been wondering about the lactose project because it was a big project and people want to know how it went. So I took the therapy back in February, and so it's been about 5 or 6 months now. And I mean, I decided to bring along a prop because I wanted to make a point. Yes, still working. Basically, I've had no side effects. It's really been great. And I've actually noticed that over time, like right when I first took it, I mean, even so, the days before I took the therapy, I was still suffering from all the usual lactose issues. But 2 days after, I was able to do what you saw in the video. Ate some pizza, was totally fine. A little bit of discomfort, but it was, I think, because I mean, it literally, there just hadn't been enough time for sufficient gene expression. And the way these things work, it does take a little bit of time. And even in the original study, they saw that there was greater gene expression after about 6 months. So 6 months later, and I actually think I'm kind of feeling that thing in as much as like I'm having even less problems now. So now there's absolutely, like, I can eat whatever I want, no discomfort. It's been really weird though. Like, I wasn't planning on changing my diet to include just copious amounts of lactose, but it's one of those, like, it's easy, it's convenient, and it's delicious. And casomorphines are a thing. So it's one of those when you don't realize you missed that stuff until you can have it again.
That stuff until you.
Dude. So yeah, that's the updates on that. There's been really no side effects as far as I can tell. I'm not dead, so we're already doing pretty good. So yeah, that's the lactose. People have been wanting to know about the SCOBY leather. So the wallet you saw get made in the original video wasn't actually the wallet that I've been carrying around. Basically 3-4 weeks after that video came out, we'd made another piece of the leather that was much thicker because a lot of people were complaining that the leather was transparent, that it looked a bit like a scrotum, which admittedly it did. But so one of the things that we found, so once we grew the new piece, I made a new wallet. And one of the things that we've found kind of consistently is that as the leather ages, it actually darkens a fair bit. And so this is the wallet I'd made. So this is almost a year old. You can see that it's totally opaque. Like, there's no, you can't see through it. Like, I'll hold it in front of the light. Like, it's really opaque. It looks like the real thing, and it's held up incredibly well. So like basically what we've been doing is, well, so first we had this tested, and it came out to be as strong or stronger than nylon of the same thickness, which was really cool considering that this is essentially bacteria paper. So that's really neat. But also because it's so strong, we've essentially been, you know, going to bars and being like, hey man, I'll buy you a beer if you can rip my wallet in half. And you know, people are really like, you know, they give it everything they can, and this it doesn't rip. And we've had, you know, people significantly larger than me and stronger than me try and do it, and nobody's been able to thus far. And it's always been the same wallet. So I've been abusing this thing for basically a year now, and that's kind of cool. And didn't know it's the wallet making channel. But no, so the reason we went with the wallet is because it's something that it's easy to carry around. You know, I can essentially just abuse the hell out of it to see what its breaking point is, and thus far it hasn't failed, which has been really, really fantastic. I haven't re-oiled it. I have, well, actually that's not true. I've re-oiled it. I haven't re-waxed it. So any waterproofing that's on here is the original waterproofing. Every now and again, I will hit it with a little bit of mineral oil just to make it look nice, because it does get a bit of a weird coloring to it. But yeah, so that's the SCOBY leather. What was the other one? Oh, people keep asking about the cerebrolysin. I mean, the like effects wear off in as much as like you stop noticing it, but it's not magic. It's not like, I don't know. It was nice while I was on it, and for a while after, felt good. But I mean, then you just kind of normalize. You don't really notice much after that. So yeah, there's not really much to update on that. It's, I don't know. it was a neat thing. That's kind of it. Oh, so the styrofoam worms and the plastic eating fungus. So the plastic eating fungus has been, that was a really, really interesting experiment. I believe we mentioned it in the video, but if we didn't, the reason we ended up stopping that experiment was because the species that we were using as a defense mechanism produces two compounds, one of which I can never remember the name of, but the other one is paclitaxel. Paclitaxel is, well, it's a cancer drug in as much as it's a directed poison. So we ended up stopping that experiment because we wanted to take some time to essentially go in, knock the genes out for that, let the fungus produce those toxins, so that it was much safer. Because, you know, if we're going to make the thing tolerant to salt, it's probably bad if it can live in blood and is poisonous, so, or toxic. So yeah, we have reordered a new sample of the fungus. And so when it arrives, we're going to be doing some work to, you know, go in and knock out some of those genes, make it safer, and then continue the work with the plastic degradation aspects of it. As for the styrofoam worms, I have actually picked it up and tried it again at one point, but the when it got set up, my instructions for how to set it up weren't followed. So people threw a bunch of other nonsense into the bucket, and it completely screwed the experiment. So I do want to restart that, but I don't think I'm going to do it with the worms. As a lot of people have pointed out in the comments, it doesn't make a whole lot of sense to use the worms themselves, and that was never the plan. I was using the worms themselves just because it was kind of like the first test, and I just wanted to see if anything would happen. But for future iterations of that project, I'm just going to dissect open one of the worms, culture the bacteria from their intestinal tract, and then see if those can break down the plastics themselves, and then see about maybe mixing that with the plastic-eating fungus to get an even better result. So those are the updates, and yeah, I think so. Those are so seeing in the comments, magnet implant. So unfortunately, when we did the implant that you saw in the video, the one that was actually on me, because it was my friend's first time doing it, the incision was a little bit shallow, so it didn't close properly. So we ended up having to take it out. It's not a big deal. It happens. You know, this is why you go to a professional. But you know, I trusted him enough to give him a try. So when I do it again, I'm just going to do it myself because Like when I do it, as long as I don't hit it with a pan, which for those who don't know, the first time I ever did magnet implants, I did two. I did one here and one here. And literally the first day that I had them in, a pan got knocked off the counter and I wasn't even thinking, and I like reach out to grab it and it like whacks onto the new implant. So that one had to come out. But the one that I did in this finger lasted for a really long time. The only reason it had to come out was I honestly can't sit still. So I just like I'd sit there and I'd just play with it. And so after like 6 months of that, I must have damaged the coating or something, and it was like, okay, it's time to come out. Speaking of which, I've also had a bunch of comments of asking when to know when the magnet needs to come out. So it's not like a time thing. In theory, if you treat it well, like it never needs to come out. You can tell when it's gone bad. It hurts a lot. Yeah, and for that, the honestly, the way to take it out, I mean, if you can, go to a doctor or something. But when I realized that my coating had failed, what I did was I just took a scalpel and made a little tiny incision on top of the magnet so that I knew I wasn't going to like cut into something important, and then just got a big magnet and held it close and just like whoop, came right out. So yeah, that's magnets and how to know when they are foobarred and need to be removed. Okay, so that's updates and magnets. Oh, and following up on that, somebody asked what my first biohack is, and I'm going to talk about that word in a second. But my first biohack, in real loose quotes, was the magnet. That was the first thing I was like, yeah, I want to do this. This sounds cool. So speaking of biohacking, because a lot of people have been asking, like, when are you going to do the next biohack? Couple of things. So the next project that we had planned was, and I actually teased it in one of the videos, was the thing with the magnet implants is that it's kind of big and it's bulky and it requires like this whole procedure to get in. So I've been kind of trying to figure out if there was a way to make a tattooable magnetic thing that would basically do the same job as the magnet implant, but without having to cut you open. Because if it can be done with a tattoo gun, then it could literally be done anywhere. So I made I made my first attempt at it, and we tried tattooing one of my friends, but thus far there hasn't been an effect. And I think it was both because he insisted on getting tattooed in a place that wasn't optimal, and the amount of pigment that actually made it into the tissue was very, very low. So I think it's going to be a matter of that's going to need more experimentation and testing and all that kind of stuff before we can go through on that. So yeah, that was the next like planned biohack. Now on the topic of biohacking, this is actually something I've wanted to address for a while, because people have been asking, like, when are you going to do the next biohack video? So there's I don't actually like the name biohacking very much, because it's basically become this word that journalists love using to describe doing biology outside of like an academic setting, and it's really frustrating. Because especially like when we're doing the genetic stuff, they call it biohacking. It's like, it's not biohacking, it's biology. It's not, you know what? And it's not even the craziest biology that's being done. Like, you want to see the really crazy stuff? Look at the academic labs. Like, everything that all the like biohackers are doing almost universally, at least the ones I know anyway, are kind of just reverse engineering stuff that like academic biologists have done, written a paper on, and the paper ends up in a box. Like the lactose thing. Like the lactose thing was based on a paper written in 1998. It wasn't something that we cooked up. It was literally like we were just copying a paper because nobody had tried it in humans. So yeah, that's my take on the whole biohacking thing. Will I be doing more biology? Yes. I'm actually getting geared up to do some very, very serious genetic engineering. It's a project that I've been thinking of for a really long time. So I've just been kind of been doing the planning and getting ready to order the various bits of DNA and all the enzymes and everything else I'm going to need to put the DNA together. The organism, which is just going to be yeast. And just to be clear, this is not a human project. This is some it's a bit of genetic engineering, biomaterials, and that kind of thing. I've I've mentioned it on other platforms, but basically the project is going to be attempting to produce a version of spider silk in yeast. And I'm going to get into a lot more of that when that video actually comes out, and I'll explain the depths of that project, because there's a lot more to it than that. Yeah, so I think that'll be a really cool project, because unlike most people who go for fibers, I'm actually going for bricks. But yeah, so that's that. There will be a lot more genetic engineering. I'm looking at finally doing the GFP beer, so that'll be a lot of fun, and then it'll just kind of go from there. Okay, what is next on the list? Videos. Okay, next up. So this is a fun one, because I've actually been getting a lot of messages lately asking like, hey, so did you like study engineering? Did you study physics? No, I studied biology. Yeah, no, this is one of those weird things wherein in high school I was extremely bored, like unbelievably bored. The classes just weren't doing it for me. So that was kind of when I started, going, maybe I can teach myself. Maybe I can like pick a really hard project and work through it and see if I can understand it and learn all the bits that go with it. So in high school, I started with nuclear physics, and so I ended up building a little demonstration fuser, and I was building towards like a fully functional, like it does fusion, gets up to fusion temperatures, the whole 9 yards. I was getting shielding, I was getting like radiation measurement stuff. I literally have an entire bucket of big stainless steel vacuum parts, which I'm going to be using hopefully in the near-ish future, and I'll talk about that in a little while. Oh, my battery's gonna die. Give me like 2 seconds.
I got it.
Awesome. Can I have a second slice? It's just a block.
Yes, you have the second slice.
Yes.
Yeah, one of those things I should have thought this through in advance, but I'm a turnip.
I forgot what we were gonna put in. Oh, yeah. You didn't see my comment?
It's hard to look at the comments and talk at the same time.
That's all. I want
Yeah. For those of you who are curious, Paul wanted the second slice of pizza. Oh, fusion, yeah. So yeah, back in high school, was working on a fuser. Yeah, it was really, that was kind of the moment when I'm like, okay, I can do really hard science, and it doesn't necessarily need to be something. I'm not ignoring you. It's just hard to read and talk and like keep track of what I'm thinking of. But yeah, so it was kind of the moment of, I can totally do like it might be expensive, it might be difficult, but it's totally possible to do like really hardcore science outside of academia, and that was kind of what ended up driving the rest of my work over the years. Because even when I went off to university to do bio, which I'll talk more about in a moment, the whole time I was there, I was sitting in lectures going, okay, but when do we get to actually do the stuff? Like, when do we get to learn how to do the thing? And it was all like, here's a whole textbook worth of theory to memorize that you're going to forget in 2 weeks after the exam. And like, it was really depressing, honestly. So I made it about 2 years before I was like, okay, I can't do this. And I got a new lab set up in my house, because that's how I rolled. And I never actually finished the degree. It was one of those, people give me a lot of hell for it, because they're like, you were so close, you're almost done. Another opportunity presented itself, and it was an opportunity to just do the thing. Like I got to do the hardcore science I wanted to do, and it didn't require finishing the degree. So in my head, I was like, okay, well, why am I, if I have this opportunity, why would I waste the time? Um, so um, yeah, that's kind of just been how it's gone. And then, ended up, kind of doing my own thing, and the research started going well, and the channel started growing, and it's all just kind of gone from there. So now I'm in this very, very lucky position where, so long as I keep making videos and I keep doing stuff, I can just, keep exploring my interests and learning. And the reason that the projects are so disparate, is that both that I have a lot of interest, but also there are bigger questions I'm trying to understand, and I know that I can't tackle them without understanding all the like lower pieces. So it's like, if you want to like mess with like a quantum computer or something which is not necessarily something I want to do, but something like at the top of the tech tree, you got to know all the bits that go into it. Otherwise, it's just not going to make sense. So like I was just visiting a laser facility at U of T, and like there's a laser that fills the whole damn room, and I'm being told about like, and this is what this does, and this is what this does, and it's like, I know enough about lasers to like follow what's going on, but it's like I don't know all like I couldn't build that yet, right? So it's kind of, just learn the pieces, get to the thing. But yeah, so on the topic of like book and that kind of suggestions, because I get asked a lot about like what books would you suggest, what to get you started, all that kind of stuff. Um, so if I've actually been thinking about this for a while. So rather than starting with books, I want to start with movies, because it kind of leads me into a fun little story. Um, when I was trying to figure out what I wanted to do for university, I was deciding between nuclear physics, because I was doing the future stuff and I was loving it, genetics, because that was kind of always the thing that I really wanted to do, and theater, because I like theater. Um, and so I'm kind of like circling and trying to figure this out. And I mean, it's a hard thing to do when you're in high school. Like, people are asking you to like pick the thing you want to do for your whole life when you're 18 and barely have figured out how to do anything really, um, which I find really strange. But you've got it. They make you make the decision. So I had to pick something. And so as I was thinking about it and thinking about it, and it was right around then when I just gotten into like Studio Ghibli movies, and I kid you not, I made it halfway through Nausicaa and the Valley of the Wind, and when I was like, bio, I've got to do bio. It's just what I got to do. Um, and because it was one of those, like, watching the movie and seeing the how, like, it was not quite humans versus biology. It was kind of like an idea about um, how humans can very much mess up the environment, and how, no matter what we do, the environment can always kind of push back. Like, even if we were to like nuke the world down to sand, bio would come back. That's what it does. But it was, for me, it was just really inspiring, and looking at it going, okay, well, if the bio was able to remediate the world in such a powerful and important way, it's like, I wonder if I could do that. Like, I wonder if there was a way to um, like accelerate that process. And that's honestly like what got me into bio. I was like, I want to do that. And so yeah, that's kind of how I ended up actually picking bio. Not that it ended up, but even then I knew that I was never going to do one thing. Like, even in high school, it's like, there's no, even if I go and get the degree in bio, like, the plan was to then go back and do another degree in physics and all these other things, because there's never been one thing that's like, I need to do this. But I knew that I needed to do a degree, so I figured I'd start somewhere. As to other reading and books, when it comes to like good books to read, and like good stuff to get you started, there's just so much. It's really hard to give like a concrete list of things, because it depends on what you're interested in. It depends what field of science you want to go into. So it's like, if you're going into bio, like, I mean, it really, and like, even if you're going to pick a field of science, like, each field is so broad that there's no one book that sums it up. Like if I were to tell you to like go and that sums it up, there's so like if you're going into like physics, read the Feynman lectures or listen to them ideally because he's awesome. If you're going into bio, like it depends what aspect of bio you want to do. Like somebody suggested Paul Stamets' book. Yeah, absolutely, it's a great book. But beyond that, I mean, I don't know. For me, I kind of grew up on YouTube, so a lot of my inspiration came from other YouTubers, and you know, I've learned a tremendous amount by finding just great channels that are really good at conveying whatever it is that they're talking about. So it's like if you like, even if you don't like math, go watch 3 Blue 1 Brown, please. It's a phenomenal channel. You know, if you like machining, ClickSpring. Like you like lasers, Styropyro. Like there's just such a huge list. But that does lead me into you know, somebody was asking, you know, what inspired me, like what got me into science and got me doing this. So if I had to narrow it down, there's actually kind of a mixed bag of things that led me to where I am and doing things the way that I do. So when it came to starting the channel, originally, like literally when my first videos, which were garbage, absolute garbage, I can't watch them. I cringe too hard. I can't do it. But my first videos, basically I had watched Nerd Rage's stuff, and I'm sitting there watching it going, I need to do this. Like this is it. Because it was literally doing like the hardcore science, like no BS. Like it was, I mean, if you look at his channel, like he's actually doing like novel synthesis and do like actual research and experimentation, and he was publishing it on this platform that I loved. So I was like, okay, I've got to do that. Like I got to get in on this. So I mean, my first videos were basically just like copying his stuff and going, "Ooh, I can do chemistry." But you know, it took a long time to kind of you know, find my own voice and the things that I cared about and you know, doing new things. And so that's been more of a recent development. The other so yeah, Nerd Rage was a huge inspiration. There was a couple of other channels, many of which have died, honestly. Um, and you know, I really wish I'd prepared better with like a list of them because there was just so many. Um, oh, I mean, I'm trying to think of I mean, like there was Mr. Home Scientist, Alchemical Garden. Those were big ones. I think one of the and I've talked about this not on YouTube before, but I've talked about this before. How one of my really big inspirations and for the way that I do things the way that I do comes from a makerspace in Michigan, and specifically, you know, one of the guys in charge, Chris Bowden. So like he handles teaching science to such a broad audience in such in a way that I found very, very inspiring, and I've tried to model the way that I do things after that. So yeah, that's kind of how all of this started. Really, like it was just this weird conglomeration of people making content that I really enjoyed and wanted to emulate, um, and also like it kind of being the proof that I need that it's possible to do this thing in a way that the standard story doesn't necessarily lead you to believe. Um, I mean, there's definitely something to be said for normal academic science. It's a thing. It's important. It does a job. It does a job well. Um, but there's also something to be said for doing science in a new way. Like the like people definitely still need to be held to standards. There's you know, if you're gonna do science, at some point you should be publishing, uh, because peer review is important. Like being able to put your work forward and essentially have the world go, no, this is what's wrong with it. This is what's wrong with it is super important, because no matter how good you think you are, somebody is always going to be able to find the thing that you missed. Um, so that's really important. But at the same time, you know, being outside of an academic lab also allows you a little bit of freedom that you just don't get in the bureaucracy that comes from academia. And that was actually what was the final like nail in the coffin for me that actually pushed me away from academia. It was just the sheer amount of bureaucracy. Like no matter how much paperwork I pushed around, no matter who I talked to, whichever, you know, you talk to one dean, he says okay, but the other dean says no, unless you get a supervisor. And it was like, it was this whole nightmare until eventually I just hit a wall. I'm like, you know what, I'm out. Like this is not, it's not worth it. But that's my perspective, and I'm in a position to make that possible. It is not something I would suggest for everybody, because I get a lot of people, you know, being like, hey, you know, should I not do a degree? It's like, no, like there's a lot of things that I could not have learned without going to university, and it's not the stuff they teach you in the textbook. It's dealing with rigor, and sometimes science isn't exciting. Sometimes it's really, really boring and tedious. And it kind of, I mean, it like school forces you to get used to that and get good at it. And as much as I hated having to write a 30-page paper 3 times a week for every freaking lab that I had to do, those are skills that I still use. Like being able to like pump out 30 pages worth of like technical writing in a very short amount of time. Not that that wasn't like required. I'm just lazy, so I'd put things off until the last second and then have to do it the night before. So like, you know, building that skill and the skill of you know, doing the thing. It's a skill that it's really hard to learn on your own. And there's really, far as I can tell, there isn't really a better way than regular normal school. And this was actually something that we ran into a lot while I was teaching, which is the people who were new to science weren't expecting the failure. And I think if there's one thing I can convey to prospective science students is be ready to fail and fail often, and don't let it break you. Like, because it's a thing. Like if you're going into biology, like you need to be aware that your stuff is going to die constantly. Your experiment is going to fail. You're not going to know why, and you're going to spend like 3 weeks to potentially 6 months to figure out what happened. I mean, the story I love telling is my supervisor was working on extracting a protein or metabolite or something from this weird fungus, and it took her 6 months to produce enough of this stuff. She was growing like 5 gallons of the stuff at a time, and you know, it was only getting milligrams of the stuff, and so it literally took her 6 months to make enough of it that they could test it on this very expensive antibody goat. But the math was wrong. It killed the goat, and so she had to do another 6 months worth of like work doing this, like redoing all of that work. And it was, I mean, it's crushing to have something like that happen to you. Like 6 months is a lot of time. Like there's no question about it. 6 months is an immense amount of effort to spend on something, especially a biology project. And that's one of the other things. Like with bio, sometimes you're not going to know if it worked for 6 months. I've got a buddy who works on plant stuff. If you genetically modify a plant, you have to, and you're like looking at like flower expression patterns. It takes a long time for plants to flower, potentially, depending on the plant. So like, if you mess with it, you have to wait for it to go through its whole life cycle to see if the thing worked. And that is just like, it's oppressive, really. Like it's really like, it takes a very particular kind of person to be able to put up with that. But I mean, the payoff is phenomenal. Like if and I mean, this is the thing that I always try and convey. Like no matter how hard it gets, just like persevere at it. Like it's gonna suck, and there are gonna be nights that you're probably in tears going, why am I an idiot? What did I do wrong? But you get up the next day and you keep going and you do the thing, and eventually you figure it out, or run out of grant funding, whichever comes first. Like it's a thing. Like so somebody's asking, do you have a degree? But I don't have any degree. I literally did not finish my degree, and I don't have any intention of going back in the near future. So this, I mean, that actually kind of leads me into the next point. Like people ask how I fund the research. So for a long time, it was, you know, I'd work another job or two, Like I would have part-time jobs. I'd pick up, you know, whatever work I could. But I would just funnel all of the money into my own projects because it was what I love doing. It's a lot of fun. There's nothing quite like doing science, and like the moment when something works, I mean, there's nothing better. There's literally nothing better. um, it's so for a long time that was how I did it. But now thanks to the channel growing and really starting to do very well. Which, by the way, thank you all so much for the support. It really does mean the world to me. Now thanks to my patrons and you know, all the support that I've gotten and all of that, now it's actually able to both, you know, pay for Justin Kibble and also you know, help fund the research, which has been really fantastic because it's freed up an immense amount of time for me to really like dedicate myself to doing this, and I really hope it shows. I have a huge list of projects that are coming up, and I honestly think they're going to be like, I never thought that I would, or like I really didn't think I would have something to top like potentially curing my own lactose intolerance in the same year. But I mean, that's just where I'm at. I have the time now, so I'm kind of just going for it. So I'm excited. I'm really excited. There is just so much cool stuff I have planned. A lot of the times in, I think, you know, at the end of the videos when I'm like, and in the future we're going to come back to this, I know that it takes time, and there's huge gaps of time between me saying that and actually getting to the thing. It's because I've got a lot of stuff going on, and ordering parts from China takes a long time. And sometimes there's just no better way to do it. So, you know, I kind of stagger things, and I you know, put things on the back burner and reshuffle things around. This is why I'm going to be getting back finally eventually to the plastic eating fungus. I didn't forget about it. It's just I have other things going on, and you know, other things take priority, and when, you know, I take the opportunities as they arise. And I'm also trying to accommodate the people I work with, and the people who help me out, and their schedules, and the things that they're busy with, and all of that kind of stuff. So it's kind of this delicate balancing act. And so when there's huge gaps of time between me saying a thing and doing a thing, that's why. I mean, when the most concrete example of this, yeah, like somebody's asking about the meat berry. I still want to do the meat berry. Right when I finally had the chance to do the meat berry, I kid you not, I was decellularizing the thing to do the thing. There was a huge kerfuffle with the lab, and so that, you know, went up in flames for the time being. But that lab is coming back online. So yeah, meat berry, it's totally a thing. It will happen at some point. I will get to it. It's just going to take longer than I thought. It happens. Did I mention the goat? This happens with science. Like sometimes things just take a lot of time. I'm not going to apologize because I'm still making a goddamn meat berry, so it'll happen eventually. So yeah, that's kind of that stuff. All right, let's see how I did on my list of questions. Oh, I really burned through a lot of this.
Be a t-shirt. Hashtag goat happens.
That would be a good t-shirt.
That would be a good
For,
t-shirt.
for those who can't hear Paul, he said hashtag goat happens. I might make that into a t-shirt. Oh yeah, so I mean, on the topic of you know, things being continued and projects being picked up, people have been asking about the radio telescope and plasma and vacuum stuff. So as I mentioned earlier, I have a giant bucket of stainless steel vacuum parts that have just been itching to be turned into something cool for many years. So that will happen. I think I decided on the particle accelerator first rather than the ion engine, just because I've always kind of wanted to build a particle accelerator, and it's more useful. Like an ion engine is like, whoa, it's glowy. But like, since I don't currently have the ability to shoot something into space, I wouldn't be able to like put it to use. So not to say that that's off the table. At some point, maybe. But at this particular moment, I don't have rocket launch capability. So that's it. It just doesn't make sense. Like whereas with like a particle accelerator, there is so much you can do with particle accelerator. You can do, you know, ion implantation. You can do scattering experiments. You can do transmutation experiments. Like there's just it's you know functionally endless what you can do with this thing. So, and it's also it's a really hard project. It gives me an excuse to talk about all kinds of things that I've wanted to talk about for a really long time. Like, how do you generate a really deep vacuum? How do you make a diffusion pump work? How do you like build all of these different high voltage systems and RF systems and all these things that have to interplay to be able to do the thing properly? So yeah, that's why I'm definitely thinking of doing the particle accelerator first. It is going to be a little while till I do it, just because so much other stuff has kind of ended up on the docket. And also particle accelerators are expensive. So I'm kind of like slowly, like even though I do have a lot of the parts, I'm still missing a lot. So I'm kind of like slowly accruing the parts. And so once I have everything, I'll start putting it together. And I think it's also going to go really well with, you know, and leading up to a lot of other projects. So I think that'll be good because once once you can do that, then like I mean it's just a huge list of other things you can do. And especially when it comes to like ion implantation, it's like, okay, well, if you can do ion implantation, we're like that's a very serious like semiconductor fabrication that we could do at that point. And so, you know, being able to show that that's possible, because I know like Jerry Ellsworth did, speaking of phenomenal channels, Jerry Ellsworth. You know, I mean, she did like DIY semiconductor fabrication years ago, years and years and years ago. And I've wanted to give that a try for ages. She also did a video on OLEDs, and so it's like, well, I mean, we're going to be making, you know, literal buckets worth of green fluorescent protein with the GFP beer, and I was reading a paper on, well, can you turn GFP into organic LEDs? It's like, yes, you can. So, you know, it's all this kind of stuff where it's like everything kind of just interweaves and all this kind of stuff. So there's a lot of things I would love to get to. I have a lot of time. I have nothing but time now, so I will get to everything eventually. Jerry Ellsworth. I don't know if she actually makes much in the way of videos now. She's heading a augmented reality project, which actually looks pretty cool. So I would absolutely look her up and her channel because it is just spot on. Okay. Okay, let's do a couple of quick ones. Why is there stuff from different countries and where am I from? I literally get this question on every, like, no matter how many times I answer this question, I still get the same question.
Fucking jam.
I know, it's like somebody saw Polish jam and they're like, "You're from Poland." No, I'm not. They just sold Polish jam in the supermarket that I was at. So to clear this up, hopefully it's not going to be once and for all. It doesn't matter how many times I answer this, I'm still going to have to keep answering it. The reason you see stuff in Portuguese is because I spent a bunch of time in Brazil. Sometimes you'll see stuff from Chile. I spent time in Chile. Sometimes you see stuff from Florida. I spent time in Florida. At the moment, I'm in Montreal. I'm from Canada. I'm Canadian. If you haven't noticed the you know, beaver riding a Canadian goose, I occasionally, you know, throw up on the screen just because, let's be honest, that should be the Canadian flag. No, I'm kidding, but partially. But yeah, so that's that. I'm Canadian. Like, no.
And then you lose 10,000 subscribers.
Yeah, right. I know. That's okay. So that answers that. So yeah, if you see things in other languages, it's because I was in other countries. Yeah. Have I experimented with thermal cameras? No. I'm hoping to in the near future, but that's a discussion for another day. Am I a ham operator? No, not yet. I do want to. Yeah, I'm at, for those wondering, and this is an op amp. People who keep asking if it's a diode, it's an op amp. Um, I know, right? Yeah, so I'm at Food Lab right now. Um, so this is actually a ham radio club, so I could use their call sign and that kind of thing. But I do want my own call sign. I wanna be a licensed operator. At this point, I do enough radio stuff that it seems silly to not have my license and only do like receiving stuff. Not that I really want to transmit. I don't find like talking to people over the radio fun. We have the internet. The quality is better and faster. Like people are like, I talk to people in California over the radio. I'm like, I talk to people in like Beijing in about 2 seconds at any time of day, regardless of weather conditions. It's the internet. It's amazing. Um, but one of the reasons I do want to be able to transmit is because then I can do stuff with like radar and there's just a lot of other stuff you can do when you aren't limited to receive only. Um, and you know what? Maybe I will try to do some like long range like communication stuff. It could be fun. If nothing else, it would be a good like educational thing, like explain how it works and all that kind of stuff. But it's not something that I'm overwhelmingly interested in. Um, I like the more scientific aspects of radio stuff. That's why I like doing the astronomy and pulling stuff from satellites. Like that to me is a lot more fun. Um, Speaking of pulling stuff from satellites, we're still working on GOES. Oh boy, was that a more complicated project than I thought it was going to be. Um, but it happens. I mean, I basically maintain a level of infinite optimism that everything's just going to work, even though I know that it's not. Um, so we are working on GOES. We will get to it. It's literally we just keep poking at it and keep trying stuff, and eventually we'll get it working. And when we do, that video will come out. Somebody's asking, how did I start working with RF stuff? So I have a friend named Artem, who, if you haven't already, go over to his channel. It's called The Art Lav. Art spelled A-R-T, Lav, L-A-V. He does phenomenal stuff. Completely underrated channel. I would absolutely suggest checking out his stuff, though he doesn't post a lot at this particular red hot second. So when I met him, we were kind of like talking about like, hey, this is when we both just got to Brazil, and we were kind of talking about like, hey, I brought this stuff. He was like, oh yeah, I brought this stuff, and he mentioned that he brought a Hack RF, and I'd never considered working with radio. I was always kind of interested by it because it's so weird, but I didn't know anything. And he's like, well, we can use this to get data off of satellites, and I was like, what? Like tell me more. And it's just been like down the rabbit hole since then. Like after like the first time that we actually got an image off of one of the NOAA, one of the NOAA. Did we get NOAA first? I think we got like a really crappy image off of NOAA, and then we switched to Meteor and got like a gorgeous like color image, and I was like, I'm sold. I'm hooked. I can't not do this now. Like this is just too cool. So it's just been kind of a rabbit hole from there, and it doesn't seem like I'm stopping, because it seems that now every time I encounter a new like really advanced physics thing, there's always, or not always, but there's almost almost always some aspect of RF stuff kind of built in. I mean, for example, the laser lab that I was just at, they were using a femtosecond laser to generate electron packets, and they were compressing the electron packets with an RF cavity. And this was like this really cool novel thing, and they were one of like 2 labs in the world that does this. And I'm looking at it going, I recognize that hardware. I know what they're talking about now, and it was just really cool. So yeah, I'm definitely going to continue doing RF stuff. Speaking of which, I meant to. Speaking of interesting RF stuff, magical bag of parts. So something I've wanted to do for a really long time is cold plasma. So it's a really weird thing where it's like you can have very high electron temperatures but very cold ion temperatures. So you end up with this, essentially it looks like a flame, but it's cold to the touch, like it won't burn you. But because it's all ionized, it essentially just rips bacterial cells apart because they just don't have the shielding to deal with it. Whereas like our skin is so thick that it doesn't bug us. So you know, there've been really interesting videos where they essentially like sterilize a piece of food with this cold plasma, and then they just leave it, and they have a control piece next to it, basically just in like 2 beakers. And the bit that's been treated with the cold plasma just doesn't rot. Like it just takes so much longer to rot because it just all the bacteria is gone. So I thought this would be a really interesting thing to play with. It would mean I'd have essentially like a cold fire, which is just, it's such a weird thing to think about. Like when somebody's like when you say fire, people go hot. Like there's at no point do you go like fire, cold. Like it's a weird thought. So yes, the food is safe to eat. That's the nice thing. It doesn't damage the item. It just sterilizes it, which is kind of cool. And so especially for things like say the magnets, where you know it needs to be sterile before you use it, like it's a really interesting way to do so, because normally you have to either autoclave or use like chemical sterilants or like gases, but this is just like a, you know, you need helium and like a cheap set of parts from China potentially, and it should just be able to do that. So yeah, I'm really excited to give that project a try. Speaking of updates, I realized that I forgot to do one. The DNA extraction beads was a really fun project. I'm glad I got it to the point where I did. So what ended up happening was I made a big batch of the particles. I sent them off to six people around the world, and only one of them actually sent me data back, and actually ended up using the entire supply of beads that I sent them. So I basically, because I've been moving around, I literally didn't have my equipment to be able to make more of them. So hopefully I'll be receiving that equipment shortly-ish, and then I'll buy the chemicals again to make more of the beads, because as far as I can tell, the beads work. They are actually able to move very significant quantities of DNA between solutions, which I think is fascinating. I'm really glad it works, because it was like this crazy crackpot idea I had when I was like it's bored in class, like the one genetics class I decided to actually attend. You know, he was talking about, you know, how do you like how you extract DNA, and he was like talking about these different. I'm like, all of these seem really inefficient. Like, what if you made these two shmoo? And you know, when I asked him about it, I'm like, hey, can I come test it? He's like, yes, sure, absolutely. So I made some of the particles, came, tested it. It showed some promise to be working. So that whole project was basically just like I wanted to see if it actually works. So I spent more time tweaking the synthesis, making sure it was as good as possible before sending them out, and it seems to actually work. Will they compete with like the stuff that you can buy on Sigma or Thermo? No, obviously not. But being able to produce a thing that actually like consistently moves DNA, like is able to quickly extract DNA from one solution and move it to another is, I think, really cool. And especially because of the price of the starting materials, it's a really attractive option, because I can like the amount of like money that it goes to make a literal bucket of those beads is nothing. Like you need all of like 4 chemicals. You need the 2 iron salts, ammonia, and sodium silicate. Like all of those are extremely cheap. So being able to buy bags of the stuff and then just like crank out as many of these DNA extraction beads as you can, I think is really cool. Of course, you need the hydrothermal reactor, but that, as these things go, those aren't expensive. It's like $100, you get one, and then it's a one-off fee. So I definitely do want to come back to that project. I'm just waiting for just like everything I've already talked about. Like science is a waiting game sometimes. I'm just waiting for that to kind of like cycle back around. So I will get back to that eventually. For those of you waiting for another round, I'm sorry it's taking so long. I promise I will get back to it. I will make more as soon as I'm able. Okay, moving down the list. I'm almost done my list of questions, so I'll start taking yours shortly. Yeah, so can I make more radio videos? I already covered that. I will be. Somebody asked, what is the next step of the entanglement video? So the immediate next step is, I mean, making the entangled photons. That's like the big one, because there's no next step if I haven't managed to do that. Um, and yeah, so step one, make entangled photons. But like once I see the ring, which by the way, if you haven't already, go follow me on Instagram. I post pictures there all the time. I just posted some pictures from my time in the laser lab where I got to see how the professionals make those kinds of photons. And like you could see that the super clear ring of the like photons that come out of nonlinear crystals. It was really cool. It was just such an awesome experience. And so now I know exactly what I'm shooting for, and also I know like the distances for things. Like it was for me that was super helpful being able to like see the guy hold a like a card in the path of the beam, and now I actually have a sense of like, okay, where do I need to put the screen, um, past the crystal to be able to see that ring. Because I thought it was a lot further away than it actually is. It's much, 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 much closer to the actual crystal. So the next steps of the entanglement video are step A, make the photons. Once I see the ring, then I know that I can actually start experimenting with it. And then as a bajillion of you commented, the next step is actually proving that it's entangled. So the way that you do that is with something called coincidence detection, which is basically you have two detectors at different points of the cone, and they have to be photomultipliers. This is not a thing that you could do with a camera. It has to be photomultipliers or similar, but really it should be photomultipliers because they're the most sensitive. And so basically what you do is you see like, yeah, here. Thank you, Paul. This is having stagehands. It's so helpful. So yeah, you need one of these. Which are really, I mean, they're just really cool little devices. I love photomultipliers. So it's literally a vacuum tube. So that's the actual input side. So basically what this is able to do is if a single photon hits one of these, it basically kicks off a cascade of, like one photon hits it, an electron goes flying off. But because all of the electrodes in here, that's why there's so many little pins. These are all sitting at a very high voltage. So basically, once one electron comes flying off, it hits one of the other electrodes, called the dynode, and it knocks a bunch of electrons off. And this just kind of cascades until the pin that is the actual like reading is getting a huge comparatively signal, even though it only started from one photon. So we have two of these set up for coincidence detection. Basically, what you can do is if you get something coming in at and hit both photomultipliers at exactly the same time, then you're able to start actually exploring the properties of like the entangled photons, because then from there you can start doing the like quantum eraser experiment. You can start like doing the Bell inequalities. There's just so much you can do with it. And it was actually really great. After I posted that first entanglement video, somebody sent me a message saying like, "Hey man, I found a sale on BBO crystals. So instead of having to spend like $3,000 on a crystal, it was like $40." It's like, yes, sold. So I think I might actually need a second BBO crystal, because I think you need to have two back to back and off axis to be able to actually make entangled photons with that type of crystal. But then they come out in like two very distinct locations. So it's much easier to find them. But then once you have that, there's just so much more that you can do with it. Like there was a great paper I was reading about a test of pilot wave theory, and they were using entangled photons made with this type of crystal to be able to do it. It was a huge and complicated setup. I do not think I'm going to be able to get that far, and I have just too many other things going on to ever really try for it. But it's more of if I can show that quantum entangled photons can actually be generated using a relatively inexpensive setup, then I hope that it opens the door to other people who are um, interested in quantum communication and quantum entanglement and all this kind of stuff. Because the point of this channel isn't necessarily for me to do the like world-changing, magical, wonderful science. It's more, I mean, sometimes, but a lot of the time it's more to encourage all of you to do your own experimentation and share your results and publish good data and all that kind of stuff, because there's only so much that I can do. Or it's one of those, it doesn't matter how much of a wizard you are. Like, if you have a team of 100 people, even if they're all a fraction of as good at a thing as you are, they'll probably be able to like work their way through it eventually. It might take them a little longer, but monkeys and keyboards and all that kind of stuff. So I'm much more interested in rather than like doing it all myself, I would much rather inspire all of you to do stuff. Oh, somebody's asking about carbon nanotubes. I don't know. I'd like to circle back to that. We've been starting to talk about coming back to the supercapacitor stuff. That one I think is going to be a while before I get back to it. I just have too much other stuff going on, and supercapacitors are when I first started the supercapacitor project, I was not expecting how difficult. I mean, I kind of was. It's literally $1 billion project for all these other academic labs. Like I somehow managed to delude myself into thinking that like me being some schmuck in my kitchen, like futzing about with conductive paints was going to be enough to outpace the rest of the industry, which was stupid. At this point, I actually have a pretty good idea of what it'll actually take to make a supercapacitor that actually like fits the bill, like does the thing that I want to do. But it's very like equipment intensive. It's not necessarily expensive. It's just like the equipment requires working with things that are not pleasant, so that even the finished supercapacitor will very much be environmentally friendly. Like the goal still is to make a capacitor that is so safe that you can eat it. I wouldn't, because if it's charged, that's going to do all kinds of gnarly stuff to your stomach. But the idea being that like an uncharged battery would be so safe that like there's nothing in there that can hurt you. That I still very much intend on shooting for, but making those materials requires working with very, very high temperatures, extremely corrosive liquids, and extremely corrosive liquids at very high temperatures. So it's a difficult thing to do. It's something I really want to come back to. I don't get me wrong, I want a magical battery that outpaces lithium and won't explode. But it's just a lot of work, and I'm just not set up for it anymore because of the moves. And I mean, this is the other thing. Like every time I move, I leave equipment behind. So even though I was ready to go, the kiln was built, I was ready to do the thing, and then I had to move. So life throws curveballs constantly. It happens. I will come back to it. I will come back to carbon nanotubes eventually, but it's just not a priority right now. I just have too much other stuff going on, and I'm having too much fun doing other things. I want to come back to it. I do. I really do. But other things take priority. Okay, that's that one. Somebody asked, where do I get project ideas from, and what was my favorite project? That is, it's actually an easier question to answer than you'd think. A lot of it comes from like, I'll either read about something or hear about something, and then I'll start digging into like how it works, because I'm constantly just like the way I got to where I am was I'm constantly reading. Like there was a point when I was legitimately reading as many nanotech papers as I could every single night. Like there was at least a week when I think I probably burned through like hundreds of papers. It was awful. But you learn an immense amount by just like take the time, read the literature. But a lot of it's like, I go to look something really simple up on like Wikipedia, and I start reading through the article, and then there's something that I don't understand, and so I click on it, and then you end up with like down this whole rabbit hole of like, oh, well, here's this weird phenomena that makes this other thing work, and so I'm like, okay, well, I guess I gotta mess around with this other thing then. So yeah, the ideas basically come from like conversations with people, things I read, rabbit holes I end up down. It's a really weird mix of stuff, and it's just like things I'm interested in. That's kind of it. As to favorite project, I don't actually know if I could pick one. They're all kind of fun. At the moment, probably the lactose one because it quite literally changed my life. But I don't know, and was also one of the most like technically demanding, in as much as like I had to do a lot of reading before I did that one. Because people are like, you're gonna get cancer. It's like, well, you don't think I took the time to make sure that I wasn't gonna like get sick, really? Like, I, before I went anywhere near those pills, like I did a lot of reading to be like, okay, well, what are the actual risks? Like, what is the likelihood that this is going to go bad? And all that kind of stuff. So, yeah, that one was probably that one's probably my favorite in as much as it was the most life changing. But like, there is rarely a project that goes by that I'm not like, this is the coolest thing I've ever done. Like the Wi-Fi camera, like it doesn't seem like it was not as complicated as the lactose thing. It didn't require putting my life on the line, but the result was really damn cool, and I had a lot of fun making it. So yeah, I mean it's just kind of a hard question to really pin down, in as much as I'm just having too much fun. I'm having too much fun to ever pick. It's like, it's like trying to choose your favorite kid. We all know that you have your favorite one, but you never really admit it. Okay, last two on my list. Any videos about water quality or treating water? Actually, maybe, because I just tested my water this morning and found out that it's got heavy metal contamination. So, yeah, right? Yeah, they're like, Montreal water is so good. No, it's not. You got to test that regardless of where you are, regardless of where people, like, what the government tells you, because unsurprisingly, they're not super honest. They test for very specific things, but they, for whatever stupid reason, they don't, like, a lot of the time they don't test for like mercury or lead or copper, like, the things that really do the long-term damage. And we've actually done a fair bit of experimentation with how to remove heavy metals from water. Like, we found a paper where you can use, I want to say it was parsley. It might be, no, wait, it was cilantro. I think it was cilantro. It was such a weird paper where they'd basically like made a filter out of cilantro. Like, it was like a tube just packed full of cilantro, and they just flowed the water through it. And it dropped the heavy metal levels. And we tried it, and it totally worked. And we're like, this is like the dumbest smart thing I've ever seen in my life. It's just so I would love to do a video like exploring that. Of course, it does have the downside if you need just copious amounts of cilantro lying around at all times. So that kind of puts a damper on that. But there's other things you can use. We were like, at one point we were exploring the use of chitosan for removing heavy metals from contaminated water. So yeah, I would love to get to a heavy metal thing at some point. I'd happily do that as a one-off video. Because people are like, oh, I can just get a carbon filter, right? No, heavy metals go right through carbon filters most of the time. They'll drop the level a little bit, which for Montreal water, or at least the water out of my tap, actually seemed to be okay. Like, the level was low enough that the carbon filter did manage to drop it to a level I find acceptable. But for like the really bad stuff, like all the stuff in Brazil, yeah, it doesn't do anything. Like, it just goes right through. And you're like, yeah, I'm still getting terrifying amounts of heavy metals. It's one of the reasons why, like, talk to anybody in Florida, anybody over 40's got like a bad case of the like shakes, and all the old timers are staring down dementia, and they're like, I have no idea. I guess it's just a thing that happens when you get old. It's like, no, it's a thing that happens when you spend your whole life drinking heavy metal contaminated water. So yeah, I'll happily do a heavy metal thing. How positive? I don't know. Can you read a test strip? Like, that's as it may be a false positive. You're right. I'll run another one just to be sure. And I mean, like, it could just be my water. It might just be copper. It might just be an old building. There's a very high chance of that. I mean, that was what we suspected when we were in Brazil at first. We were like, okay, maybe it's just an old building. So, of all the things that could be in there, copper is not the worst. If you get just egregious amounts of copper, then you can get like Wilson's disease and stuff. But like, you can process copper for the most part. It's really the mercury and lead and that kind of stuff, because those are like neurotoxins. Those are the ones to really be worried about. So even though the test strip did show that there were heavy metals in the water, it doesn't say which. So it could be one that is a lot less bad. It could be one that's more bad. It's hard to say, because the way that the test strip works, and I've actually dug into the patent to see how, like, what it's checking for and how this works. It basically is just looking for metals that are in particular oxidation states, that are much more common for the heavy metals, which it's like if you have distilled water, there shouldn't be anything with things in those oxidation states. So could be a false positive, could be something harmless. Either way, I don't like to risk it, because you know, I like my brain working. Dementia is terrifying. I'd rather not get it if I can avoid it. So yeah, that's heavy metals, and I think the last one, yeah. So the last question I have before I'll start going through the comments and answering all y'all's, is, do you need to start early to be a good scientist? No. This is one of those, there's this like weird push that, you got to be successful early in life. Well, I mean, ideally, just because I don't know if you've noticed, our planet is kind of broken. I don't know how much time we have. But no, I mean, there's so many, for every one story you hear about some like Silicon Valley kid who like did a thing, got really rich, or like some young scientist who did a thing, there's 1,000 more of people who spent their whole life doing a thing and taking their time and learning slowly and getting really good at what they do. So no, you don't necessarily need to start young. Like when you're young, have fun. Like it is the only time in your life where you're like not being held by a bunch of responsibilities necessarily. Maybe you are. Maybe that's your situation. I mean, everybody's different, but you know, don't think that you need to start early. Just like take your time, learn and get good at what you do. That's what's important, and learn not to be, as I said before, learn not to be dissuaded by failure in science if you're doing something hard. There's definitely a conversation to be had for like letting things die when you're like, okay, this is not working. But and also learning when to pivot. Like that's the other big skill. But yeah, you don't necessarily need to start early. I mean, look, like I mean, same with like actors. Like, there's a perception like you need to be young to get into the acting world. I mean, look at Professor Snape. I'm blanking on his name at the moment, which I feel shame for. But like that dude started his acting career when he was like 40. So yeah, it happens. But yeah, so that's all my list of like prepared questions. So I'm gonna start going through the comments, and so if you guys have questions you want me to answer or things you want me to talk about, just let me know. I'm gonna just enjoy some pizza for a moment while I wait for the questions to come in. You have a turbo pump, dude? Turbo pumps are awesome. I don't know, any kind of uh, any kind of vacuum stuff, man. If you can get a functional turbo pump, like it's funny, like the academic institutions are all phasing out diffusion pumps, which is kind of a shame. Like I like diffusion pumps. They're like a self-contained thing. There's no moving parts. If they break, you can just run them forever. Like the what kills them is the if the heating coil dies or something, or like they run out of oil. Like as technology goes, I like things without moving parts if I can avoid it. But turbo pumps are better at their job. So there's something to be said for that. Will you ever attempt to communicate with the ISS? Maybe. Something I wanted to do, but you got to schedule that. Since I'm at like a makerspace, that's an event I might hold at some point. Honestly, it had just kind of slipped my mind. I hadn't thought about it in a while. How's the new antenna? It kind of works. It works as an antenna. We just weren't able to see goes consistently. Like we saw a signal that looked right in the right spot, but when we tried to set it up the next day, because we were tired, so we packed it in when we finally got that working. When we tried to set it up the next day, we didn't see the signal again. So I think that might just be because goes is just at the like it's just too far out of bounds for the capabilities of that antenna. So we're going to be doing stuff at a little bit lower frequency because of the date. I'm actually really excited about this. Things I never thought I would need to care about. The moon is actually in perfect alignment right now. That we should be able to receive the signal that the transmitter in Belgium is blasting at it. So we're going to be trying that in shortly. I mean, I might do that tonight or in the next day or two while the alignment is still good. So yeah, definitely going to keep messing with the antenna. So that'll be fun. What else we got? I've already answered the where do I draw? Oh, actually no. Well, limitless motivation and work ethic. I don't know when to give up. That's it. It's best I got. I don't know. I don't know when to quit. And I get a little bit obsessive with things. Like when things don't work, it just bugs me until they do. So I just keep like poking at things. I don't know. It's the feeling when things finally do work is just such a great feeling because you know that you've achieved something really cool. How long until I build my own satellite? You know, it would be less time if my if things had worked out better. There was a moment when it looked like I might be able to borrow some launch time. I would love to build a little CubeSat if like because like building the CubeSat is not the expensive part. Launching the CubeSat is the expensive part. So it's like if I don't know, if somebody's out there and you can get me a launch, sure, man, I'll shoot a thing into space. I'm not going to say no to that. That would be awesome.
You must call me.
Yeah, right. Hey, Musk, if you're listening, mind if I borrow a spot on your rocket?
I'll settle for Merlin and
yeah, right. I'd settle for just rocket parts. That'd be fun.
product placement time.
It's not sponsored. I can't. Okay, what else we got? Laser eye surgery. My thoughts on that. Yes, oh my god, yes, please. I hate glasses so much. I would like I've honestly just been waiting for my prescription to stop getting worse. So that I could actually do that. Like I mean it's you can't tell, but like that's the thickness of my glasses. I'm like functionally blind. I've wanted laser basically like from the day that they were like you need glasses. I'm like I need laser is what I need. But I was like 12, so they're like you're gonna need to wait. I'm like damn it. What about contacts? I don't know if you would have you worn contacts. Like jabbing your finger into your eye every morning is not actually fun. How can you make an antenna from scratch? Get 2 pieces of wire and a pencil. I don't know. It depends what kind of SDR stuff you're trying to do. I saw a good question. I don't remember what it was, but I'm trying to. Do you still have the RFID? Yes, I do. There is. I'm trying to see if I can find a good angle to show you this, but yeah, there is still a chip in my hand. I don't use it for anything. Like if you scan it, I think all it says right now is butts, because I have no use for it. I got it because like this would be neat. And it makes for an interesting like conversation point, but I honestly have no use for it whatsoever. I mean, I don't even think it has as Paul suggests I could use it to get in the door. I don't even think it has enough read range to be able to do that. Like I'd have to get one of the new like Flex implants just to be able to do that. And like, that is a much bigger operation than like just stick and push. Like I don't care enough to do that, so I don't think I'm going to anytime soon. Could you build a dynamic bandpass filter with flexible material? I think, I don't know. It's not my field. I don't know enough about that to really answer.
Have they been Googling my name?
Maybe.
Been any InfoSec projects?
The couple of people have been asking how do I make money? Patreon. If you would like to help the projects, check out my Patreon. It's greatly appreciated. I missed a bunch of these. Okay. So many people ask about magnets and airports. I don't know if you know this. Airport security is bullshit. Like, their magnet detectors require like very large hunks of metal to be able to actually detect anything. Like nowadays, like I walk through wearing jeans where like the buttons are definitely metal and a lot more metal than that tiny ass magnet is, and it doesn't set off the detector because they don't care. Like they want you like those detectors are meant to pick up hunks of metal about I don't know, gun sized, like things that set off metal detectors. Titanium knee implants apparently, but not magnets. I went through so many airport detectors with a magnet in, nothing happened. Like you'd have to like touch the sensor basically, and even then, I don't even think it's calibrated to be sensitive enough. Like I can't believe that this actually needs to be said in 2018. It's all theater. Like security is bullshit.
Security theater.
There have been many books written on this topic. Yeah, so yeah, somebody's talking about they had an MRI done with a magnet in. As long as it's like one of the low strength MRIs, you'll probably be okay. Like there's this weird misconception that like the magnet will just get ripped out of your hand. Maybe if you got into one of the like 5 or 10 Teslas, but like a 1 Tesla MRI doesn't actually have a lot of pull to it. Like a neodymium magnet is 1 Tesla, potentially, like one of the big ones. It would hurt if you like put a, like so the thing with that is your skin is actually incredible stuff. Like it has a lot of tensile strength. So it takes a lot to like actually yank something through your skin. So it might be very uncomfortable to be in an MRI, but as long as it's one of the low strength ones, it probably actually won't hurt you. You'll definitely feel a tuck. You'll feel it. You'll like I know people who like stuck their hand into an MRI with the magnet in just to see what would happen. It was, from what I've been told, it's uncomfortable. I like also freaking tell the tech if you're going to do that. Like let them know that it's in there because unless there's a reason for you to get an MRI rather than a CAT scan, we'll just give you a CAT scan. Obviously, that exposes you to a bunch of radiation, so this is a decision that you need to make for yourself and with your doctors. But like they built CAT scans specifically to image you if you're full of metal, because unsurprisingly, MRIs are not super great when people are full of metal. So yeah, just yeah, if you're gonna get an MRI, it's probably fine, but just let your doctor know. And if it's a big enough deal that like you need an MRI, take the damn magnet out. Like it takes 3 minutes to get the thing back out. Like they throw a band-aid on it and you're good. Get in the MRI and do the important thing that you need to do. Yeah, like if you're getting into an FRI, like an fMRI, I usually those have like way stronger pulse. Like you need a lot more magnetic field to be able to like see what's going on in your brain. So yeah, don't be stupid is I think the best advice I can give about this. Like you're getting into an MRI with a magnet in you. Tell the tech, don't be stupid. Fair. Somebody asked how the lactose therapy is. I think I'm just gonna like take a bite every time somebody asks.
I could get more pizza.
Yes, it works.
We have a tube of cheese.
Yeah, right. I feel like I just need a glass of milk. That was actually the thing that took me the longest to do. Like, even though it was working, I was terrified to actually like drink a glass of milk or have ice. Ice cream was the thing, because ice cream is basically just like cold milk.
I see that.
Actually, it's worse because it's cream, so it's concentrated cold milk. Favorite cheese? Brie. so far. I've always loved brie. Somebody's asking about educational background. I already talked about this. I went to school for bio, dropped out, got bored. That's, yeah. Are you officially a GMO? Yes. I am a genetically modified human, and it's awesome. Take that with a grain of salt. Would lactose therapy work for gluten? No, I was thinking of doing a journal club video specifically talking about why gene therapy isn't magic and can't just deal with like a bunch of different conditions. Gene therapy is really good for things where a gene is broken. So alcohol flush, lactose. There's another liver one. It's like you can't eat protein basically because you can't break it down. Ketonuria. I'll look it up.
Probably gluten intolerance too.
Yeah. Phenylketonuria. That's the thing. That was bugging me. Yeah, with phenylketonuria, you're missing an enzyme that lets you break down things properly. So you end up with I think it's just too much urea in your blood or something. But it's one gene. So gene therapy, really great for that. Gluten intolerance is really complicated, and we don't really understand what causes it because some of it's a genetic aspect, but some of it isn't. So it's not like you can just apply a gene and make it go away. It's just weird and it's complicated, and it would take significant effort to do. Which sorry, but science is a bitch sometimes. What else? Would you? No, I would not. I don't intend on letting other people test the lactose pills. If that project evolves, it's going to need significant more testing before it ever gets tested on people again. The only reason that I jumped at the chance was because I knew that my time was limited, and there was a chance that we were going to lose that lab very shortly. And it was one of those I'd checked the research. I knew that there was a risk, but it was within the realm of risk that I was willing to take. And also I knew that I checked all the things that could go wrong, and came up with solutions for if any of those things came up. Like, what do you do? Like, if you do get cancer, what do you do? Well, it's like, okay, well, you build a thing that targets the weird new protein that you've got floating around. It's of all the types of cancer to get, the one where you know what's going wrong seems like the easiest to treat. Obviously, that I'm vastly oversimplifying, but that was why I did it. But before I'd let any other human go near that shit, it needs a lot more testing. What else? I've already talked about the superworm styrofoam thing. So if you're interested, watch the earlier part of this. Am I planning to visit Argentina? Not anytime soon. South America was an interesting place. I don't intend on going back anytime soon. It was strange, mostly. I could get rich with these pills. This is true, but I don't intend on releasing a thing until I know that it's safe at large scales.
Unless you can afford.
Yeah, will I ever make my own weather balloon? I mean, I might buy a weather balloon and strap some things to it, but I don't know about making the balloon itself. Could I modify a chicken into a dinosaur? I mean, why would I start with a chicken? I'd start with an emu because they're already basically raptors. Last thing, and I don't need to change much. I basically just need to add teeth.
Welcome to Emu Park.
And there was a weird mutant chicken that came out once that had teeth. So there's some gene in there that'd do it. I just don't have the time, materials, or care enough to do so. I was never actually thrilled with Jurassic Park. Didn't really do it for me. I like dinosaurs as much as the next guy, but not enough to make one. Genetically engineer yeast to produce THC. There is already a company doing that. I know the guy doing it. It's very cool. I'm not going to waste my time. But I would totally just buy some of that to have around because that sounds awesome. Will I make a laser turret against mosquitoes? That's maybe. I don't know. Sounds neat. Somebody's already done it. I don't know if I care enough to use them. What books would you recommend to get into genetics? The manga guide to genetic engineering. And there was another book I read a little while ago. I believe it was called Biopunk. And it was about some people who are actually doing some like neat genetic engineering stuff. Cool. Any more good channels for education? 3 Blue 1 Brown, Nile Red, Nerd Rage, Applied Science, Jerry Ellsworth. There's Vihart. There's too many. I could not list all of them. It depends what you want to learn. There's so much good content nowadays. And the chat died for a second, so I've got to wait for my computer to die. There we go, it's back. Have I thought about streaming experimentation sessions? No. This is the only like live stream thing that I'm really feeling like doing, just because it's a chance to like interact with all of you in a more like personal way. I don't like live streaming work. I like showing work when it's done. I don't know if my personality is conducive to live streaming experiments, because it's a lot of me being quiet and then swearing a bunch. Have I thought about ion engine drones? No, because we're not in space, so that wouldn't work. Gotta wait for the chat to come back again.
We might do my wing with the ion propulsion over the wing.
Yeah, but it's not like ion engine. That's just like ion direction. It's not providing the boost.
It could.
No, it couldn't. Do you know how much power you would need to push a thing with an ion?
Do 5 minutes. But...
Do you know how much power you would need to do? Like, it's a lot. Anyway, back to the stream. Not talking to Paul. Would I consider building a cloud chamber? Yes, actually, that is something I am legitimately working on. So I found a supplier for plastic scintillators that are really nice and cheap. I've got Artem working on a cosmic ray detector. So yeah, like all of that kind of stuff is very much in the realm of things I want to do. I think I have a clever way of doing it, so we'll work on that. What projects would I like to do that are prohibitive based on cost? Oh man, there's so many. So many. I mean, there's a lot of the projects that I've already done that I would like to just do if I had, like, I'd like to redo them properly if I just had a pile of money.
Go to space.
Yeah, right. Go to space, like shoot a thing into orbit is up there. You know, crazy laser stuff, like getting into like the hardcore physics, the really hardcore bio. Like bio is expensive. Like you want to grow an organ. I would love to recellularize a heart. Like getting recellularizing a heart, getting it beating would be amazing. Oh my God, is it expensive? I've looked into it. It is so expensive because the media required to grow those cells, because you got to start from stem cells, right? So the media and the reagents that it takes to keep stem cells alive and not mess with them, because if you mess with them, they freak out and differentiate. So the media is expensive. The differentiation reagents are super expensive because they're rare and they're weird and nobody needs them. So there's only like one company that makes them, and they're like 15 grand for like small amounts, or like $1,500 for like 5 milligrams, and you need like something like 5 milligrams per milliliter of media, and you need like hundreds of milliliters worth of media. So yeah, I mean, there's so many things I would love to do if I had like magical university budget of infinite money. Bubble chamber, I can't do because I don't have liquid helium or the ability to pressurize liquid helium. Bubble chamber, yeah, on the list of things that are too expensive for me to do. Bubble chamber. I'm actually really disappointed because when I was in university, when I interviewed my professor, she gave me a piece of photographic film of one of the actual bubble chambers from CERN. And I don't know what happened to that piece of film. I know where I put it, but when I looked for it, it was gone, and I was so disappointed because it had the like spirally like tracks. I'm like, that could be like antimatter. That's so cool. But yeah. So did I go to university? Yes, I went to university. I just didn't finish university because another opportunity presented itself and I got bored. Air liquefaction. I don't have a cryo cooler or the drive to do so. I don't know. It's one of those like some technical things I would rather just like pay for the product than try and build my own machine. Like it's like making your own liquid nitrogen. I would rather just buy a tank of liquid nitrogen. Like it is slightly more expensive, but exponentially less hassle. Like for the like couple hundred or like not couple, the many hundreds of dollars it would cost to buy a cryo cooler, buy the nitrogen like thing, like and like extraction and purification, all that stuff. I can just go to Praxair and buy a dewar full of nitrogen for like 60, 80 bucks, depending on how much I want. No, they have Praxair here. Yeah, I look. So yeah, it's just like I don't know. Air liquefaction is neat. I don't know. It's an industrial process I don't care enough to try. Sorry. I will do more videos on gene editing, just not on people anytime soon. I mentioned it earlier. I'm going to be doing some stuff with spider silk and yeast because spider silk and yeast is awesome. I did not plan on moving. That was not a choice I wanted to make. Life's a bitch sometimes. You do what you got to do. Man, a video on the Haber process would be neat. I'd just be too worried about the damn thing exploding. Like, because I mean, you got to get that to reasonably high pressure. Not to say that with modern materials it would be difficult. Like I could do it. That's a neat idea. I hadn't thought about that one. Spider silk yeast and SCOBY could be. That's actually a neat idea. I like that idea. That could be fun. I haven't tried the EME. I mentioned it earlier. I'm going to be trying the EME in the next couple of days. GFB yeast is punishable in the Netherlands. That is some weird laws. Like,
mushrooms are fine.
Yeah, drugs and prostitutes, totally cool. GMOs, oh god. Like, some weird standards, man. Bioluminescent yeast. Bioluminescence is actually much harder than fluorescence. Like there are plasmids you can buy that do it. It's just really dim. A friend of mine, David Ishii, just made this huge bioreactor where he just to test it, he filled it with E. coli that had been modified with that bioluminescent plasmid, and the whole thing was like by the time it got up to like the exponential phase, like that 5 gallons of stuff was enough to like light a room. It was really cool. But the second he cut off the oxygen and stopped, like, because it's essentially like biological fire on like a mini scale. Like you need an immense amount of oxygen to be able to do that. So this is why it works so well in the oceans, because it's you tend to get that glowing effect without its dinoflagellates, but you get it when there's an immense amount of like mixing of the water and disturbing the organisms to get them to do the thing. It's much more difficult. As far as I know, nobody has made bioluminescent beer. People have made fluorescent beer, but nobody's made bioluminescent beer, but we're working on it. Did I try the leather without mineral oil? Yeah, I tried it with olive oil, and it dried out really quickly. But we hadn't added the wax yet, so it's hard to say. Also, I think that it'd have a much higher propensity to rot if you did it that way. If you wanted to do a more environmentally friendly way of doing that, you can essentially like roast the oil until it hits its smoking point. And then maybe use that. It would not smell super great, but it would actually make it a little more hydrophobic, which would be good. And then you're using all like natural stuff. Although it's a weird distinction to make when mineral oil it comes from a rock. It's as natural as it gets, as natural as uranium and bears. So, have you ever tried breeding dinoflagellates? No. I would love to try growing them though. I don't know how you breed a dinoflagellate. Like I don't know if you can play Barry Manilow on those scales. Have I tried making fungal leather? I've wanted to. I've never gotten around to it though. The guys at the other biohacking space down the road want to try that, so I might try that with them. Have I messed with quantum entanglement yet? No, I've been away. I've been busy. Linseed oil, yeah, that could also work. Double slit, I assume you mean with something other than photons. Yeah, once we've got the particle accelerator running, I'll happily throw a double slit in there. We can do some diffraction experiments. Speaking of diffraction, actually, I got to see the diffraction lab where they were like doing diffraction studies using electrons at U of T, which was super cool. That video will be coming out in a little while. Do I see ethical issues with genetic modifications? No. I mean, it depends what you're doing. It's like anything. Like, do I have ethical objections to things they do in physics? Yeah, I'm not a huge fan of nukes. What a concept. It's a hammer, man. Like what you do with a tool is completely separate from the abilities of the tool itself. Favorite crypto? Don't have one.
Ooh, I have one.
Oh, Paul has a suggestion.
ED25519.
I don't know what that is.
Just say ED25519.
That. I don't know. He mentioned some obscure crypto he's excited about.
Daniel J. Bernstein is my homie.
Yeah. I don't know. Whichever one makes me the most money in that particular week is, I think, the best. I don't know. All right. I think I'm gonna do another, probably another 10 minutes of this, and then I'm gonna wrap it up. Yeah. Wow. Talk about obscure cryptocurrency. Thank you, Paul.
Oh, he actually means cryptocurrencies?
Or crypto. I don't know.
That's my favorite cryptographic algorithm.
Oh, okay, yeah, sure. I don't know.
Fuck cryptocurrency.
I'm not a programmer. I know dick about cryptography. Do I consider myself a crypto anarchist? No. What the fuck? No.
That's the cypherpunk.
Yeah. I'm a hardcore solar punk when given the opportunity, because I'm sick of the like depressing dystopia you get with cyberpunk. We're living that already. I don't need any more of it. Thank you. I'd like some plants, please, and to go with my high tech and us not destroying the planet. What a concept.
That double adds.
Any project with stem cells. I again, this is in the meatberry department. I was gearing up to do that. There's this really also the system that we used in the T cell video that lets you extract whatever cell type you want from blood. They have a kit that does stem cells. So I wanted to extract some of my own stem cells and then play around with differentiating them and doing all kinds of stuff with it. But I'm not at that lab at the moment, so that got sidelined for a little while. Ever thought of not scripting your videos? Yeah, when I was like 16, and it was awful. So never again. Did I say meatberry? Yes, I said meatberry. It's a thing. It's on the list. We'll get to it eventually. Future projects. I'm going to bring up my list of future projects. I'll name off a few of them. I make no promises that I'll ever actually make them, because science is a bitch. Sometimes things just don't work. So I've mentioned the EME, so the moon bouncing the signal off the moon, GMO beer, the spider silk thing eventually goes. We were doing a thing where you can induce new hair growth. So that one, it works. I'm waiting to do more rounds of it on my friend. so that like I don't want to put that video out until he has like full head of hair, so that way we can be like it totally works. At the moment, he's just got like some new hair, so I'm just waiting for it to be like totally done. Yeah, some radar stuff, some radiation stuff. I want to do something with AI and TensorFlow and all that kind of stuff. I mean, it is clickbait buzzword of the day. Might as well. I really want to do some plant cell culture and plant cloning and all that kind of stuff. What else?
Oh,
Do I regret working with Aaron? Well, I mean, I don't know if regret is the right word. I like it did a thing. It was an interesting experience, and now I have a story to tell that I think tops pretty much everyone else's like story you tell at a bar. So I don't know. And it like ended with pizza. So I don't know. I think it turned out fine in the end. Probably microwave radar, ultrasound radar is neat, but I mean, I'm open to all of it. I'd give it all a try, but microwave radar is the plan. Could I calculate how powerful the TEA laser was? Yes. I've been meaning to do so. From my understanding, because people have actually done this, like it's not math I necessarily need to do. So because there's a difference between like general power and peak power. So in the like couple of nanoseconds when that thing is firing, it can well max out at over a megawatt. Like it is an immense amount of power. The big one I'm building might hit even higher. But like this concept of like laser power is a really weird thing when it's like you're putting in like so the laser I just saw, like the professional one. I think they're putting in like 4 watts worth of power, but the actual laser pulse when it's like all boosted and amplified and all this kind of stuff, I mean it's a femtosecond pulse. It's a tiny amount of time, but in that tiny amount of time, it's like technically a terawatt worth of power. So it's a really weird thing. No, Aaron is the Ascendance biomedical guy. Um, could you use the TA laser for LiDAR? I mean, I guess. I don't know why you would. Like, regular lasers are way better. Yeah, like you can do that with like a $5, like a $5 5 milliwatt like red laser. I don't know why you would use a megawatt UV laser that's very delicate. Like that's I don't know. How is the radio telescope coming along? It is coming along. I don't know. It's in development. It's coming along. As usual, lots of other things going on, so I'm just kind of like bouncing between things. Yeah. When I had the magnet in, I could feel live wires. Yeah. What else? Deleting that comment. Have I done any EEG projects? No, because I just don't care. I think the best way I've heard of like describing an EEG is it's like listening to an orchestra from outside of the theater. You can kind of get an idea of what's going on, but you're not really hearing what's going on. So it's I don't know. It's inelegant from my perspective. There's newer tech that I think is going to be much more powerful and exciting, but also terrifying. That uses like tiny little like RF transmitters and receivers and stuff. We've we got another lactose comment. Time to eat more pizza. Pizza. There are definitely some laws prohibiting particular experiments in Canada. Yeah. But that's the same like with anywhere. Like, unsurprisingly, you're not allowed to build nukes. Like, but there's also like a lot of gray area where it's like there isn't necessarily a law against doing certain things, but they really don't like it if you do. Um, it's the same like you know, when you get like if you're in a casino and it says no driving motorcycles in the casino, it's like because somebody did it. Like they didn't. There might not have been a rule before then, but there is after.
Reverse engineering is completely legal here.
Is it?
Basically, yeah.
Huh.
I mean, you
Interesting.
don't sell it, but
Yeah, so a bunch of computer stuff is illegal here. Pineapple pizza, yes or no? Yes, it is the superior flavor, obviously. Chemical vapor deposition, yeah, I really, really want to come back to the magnetron and all that, but that's going to be after particle accelerator. Like I want to get that working, and then because if that's working, the magnetron will be comparatively very easy. I'm not, you know what? There's so many other videos on making rocket engines. As much as I'd like to, I don't know. It's not my jam. There's too many other great videos doing that thing. I don't know if there's anything new I could really contribute. Somebody brought up intermittent fasting. I don't know. I don't know if there's any amount of like fasting you can really do that's gonna like radically change your life. It's like in the body hacking bucket of like people who figured out to like eat a sandwich, go to bed, and exercise. Like that's it. That's the whole fucking like. There's no amount of shark oil you can apply to yourself to make you like magic. Like it's just I don't know. You know, am I fat? No, I'm not fat. I'm quite lean. Mute you for that. Lead. This is a actually. Huh. Oh god, this is heavy. I don't know if you can hear that thud, but this is 10 pounds of bismuth. I know it doesn't look like a whole lot, but it's bismuth. It's very dense. Also, look at that crystal structure. It's so pretty. So yeah, this is going to be part of the shielding for the accelerator when it eventually gets built, because this works about as well as lead, but is significantly less toxic. So I don't mind handling it like this. Yeah, so I'm going to be casting this into some thin plates. Probably also making some neutron shielding as well out of paraffin and borax. I know Cody's lab is gearing up to do a fusion reactor. I'm kind of over over the fusion thing. There is one fusion design that I actually want to build, and it has nothing to do with fusers. Like I honestly the only fusion I care about at this particular point in my life is stuff that uses cusp fusion, where basically you have magnetic fields that like compress not the ions, they compress the electrons, and so you end up with this like super dense. No, I'm not doing cold fusion. So you end up with this like super dense packet of electrons where like the density increases towards the middle, and so when you have ions that hit it, they instantly ionize, and there's a gradient, so they get pulled toward the middle, get accelerated. There's a couple really interesting designs. Yeah, tokamaks, not a fan at all. They're super inefficient and expensive and dumb. Like they're a $10 billion shiny donut. Like it's a research tool. It's like a really good way of exploring hot plasma. I'm much more interested in Polywell and the stuff that what was the company that's doing the other cusp thing? I always, it's not General Electric. It's one of the like I want to say it's one of the weapons manufacturers. I can't remember what it is.
Raytheon?
No, it starts with V, I think. I can't remember. Either way, there's a couple groups that are working on cusp fusion stuff that I find a lot more interesting than anything a tokamak or a Stellarator or any of that stuff. Like they're gonna spend so much money on tokamaks over the years, and it's just I'd love to see one. I'd love to do a tour. Like from a physics perspective, they're very powerful and interesting machines. I just don't ever think they're going to do the thing that they're like set out to do. I'm much more interested in something like a polywell where the amount of energy is like the radius to the 7th. Like the bigger that thing gets, the more power it makes, to the point of like anything over a meter, like any chamber bigger than 1.5 meters is putting out more power than we know how to contain. Like that seems like a much more effective system than something where we're like, we need to build it bigger because money hole, essentially. Like but I mean, I don't know. It's an unanswered question. Nobody knows which one's going to be the one to do the thing. My money is on the polywell and those sorts of systems. Can I make live streams more often? Maybe. I don't know. This has been fun. But I don't know if I want to do this too often. We'll see.
Fiber laser.
What? Oh, hey, fiber laser. We were actually just talking about that before the stream started. Fiber lasers are really neat. I would love to play around with one. I already answered the styrofoam worm thing. Why the headphones? Because it's, I don't know, seemed like a good idea at the time.
No feedback.
And no feedback mostly. And also there's a mic in the headphones that is better than the atrocious mic that's in my. Not to say that the mic here is good, but it's better than the atrocious mic that's in my laptop. Did I experience EM fields in my dreams? No. If you could be one of the first inhabitants of Mars, would you do it? Not a chance. That's like the first people that are going up there, that's a suicide trip. No, thank you. I don't want to die on another planet. Like, I mean, I don't want to die, period. But like, if I had to choose, I'd like to die on a planet where I can breathe the goddamn air.
The Martian was all lies.
Hey, no, the Martian was a good movie.
It was a good
For anyone who
movie.
hasn't seen The Martian,
lies.
go watch The Martian.
Like 50 magic materials we have to invent before we can.
If you had 3 wishes, what would they be? Oh man, there's a great joke about it was like, 2 bags of chips and a can of Coke. That was the punchline. I don't remember what the rest of the joke was, but it was like, I don't know. Anytime someone's like, "What do you do? Can jet fuel melt steel beams with sufficient oxygen?" Yes, you bet it can. Also, that's dumb. No.
Even water can melt steel beams.
Yeah, right.
Stick it out a rocket engine.
Exactly.
We were talking about that last week.
Where did you live when you were in Brazil? I was in. So I wasn't actually in Florianopolis. I was near Florianopolis. I was in this tiny, weird, creepy town thing called Palhoça. It was weird. It felt like the like intro town you load into every time you play an MMO. Like there was like security guards like going around on segways around the entire little town, and like at one point somebody left their wallet in a cab. And so they called the security guys, and bars just popped up through the pavement and stopped the taxi so that they could collect. It was the weirdest experience I have ever. It was so weird. Don't go there. Biological immortality, unlikely, but I'll give it my best shot. I've already answered the P. microspora thing. Palhoça is a neat place. It is a neat, weird place. The mountain is very pretty, though. If you ever get the chance, climb that mountain. It's actually interesting. Florianopolis, and I please correct me if I'm wrong, but I remember reading that it had more biodiversity, like the jungle near that area had more biodiversity than in parts of the Amazon, which was really quite fascinating. And just kind of like wandering around the different bits of biodiversity that we found, like weird bugs and birds and stuff, like was fascinating and wonderful. Like we had these leaf cutter ants that were living near where we were. And we had some flowers on the on the front porch, and there was a day when I came outside and they were basically like taking this flower plant apart. So there was like this whole train of essentially petals just walking away. It was very strange, very cool. Pills that slow aging are almost always bullshit. Don't buy them. Algae biofuel, it's a thing I've considered. I'm going to be doing some stuff with algae soon, but that is a conversation for another day. More voltage, I don't know if that would actually help a TEA laser. They're kind of weird. More voltage isn't necessarily better. The electrochemistry stuff I mentioned earlier, I'll get back to it at some point. I don't know. I honestly, I don't know what the upper limit on TA laser is. I know what I know about TA lasers and not more. Favorite educational book? It's hard to say. Probably the Feynman lectures. They're really good. They're really, really good.
Surely you're joking, Mr. Feynman.
Yeah, right. I mean, anything by Feynman, I can just sit and watch. Like the best is listening to him go, because there's this really annoying like perception in physics where it's like everything's a wave. No, it's definitely things are particles. Like Feynman like gets up in front of the lecture. Like if anyone told you that they're waves, they're not waves. They're particles. They've just got this weird property to them where they behave kind of like waves. Could I make pills that slow aging? I mean, how much money do you have to throw at this problem? I don't, like, yeah, hopefully a lot, because it's a very difficult problem. What's your favorite flavor of Quark and why is it banana? I would say my question I never thought I'd be asked, but welcome to the internet, I guess. Favorite flavor of Quark is probably the top Quark because it's the only one that we've detected on its own. Because quarks are super weird and like they don't like being alone to the point where they literally spontaneously generate a new quark out of nothing to be its pair so that it doesn't have to be alone. It's very strange. Quarks are weird, but the top quark is so short-lived that we've actually managed to detect it on its own because it explodes before it has a chance to generate a new quark. Fusion reactor. I mentioned it. I don't know. I'm not going to bother with another fusion reactor anytime soon. I'm going to do the particle accelerator, which we'll be able to do fusion with, but that will not be the main goal of the project because fusion reactors are mostly dangerous and expensive. Like there's not a whole lot of, and like they're really good as a neutron source that you can turn off. But beyond that, I don't have a whole lot of use for them. So I don't really intend on, and like as I mentioned before, there's one type I want to build and there's not really a whole lot more I want to do with that. The hair growth wasn't minimally successful. It was successful. It requires 6 rounds of treatment to do the thing. I mentioned that earlier in the stream. We're going to get back to that. Is it possible to weave graphene into clothes? Not in the way that you're putting forward, but technically yes. There's a method for making graphene fibers, and they are legitimately the strongest fibers that anybody's cooked up. But it's kind of a pain. It's something I've wanted to do for a while. I have a bottle of graphene oxide that's just been sitting on a shelf that I've wanted to use since somebody sent. I can't. I'm sorry for whoever sent it to me. I can't remember what your name is. I've got it written down somewhere. Somebody sent me a bottle of graphene oxide. I've been meaning to put it to use. I just haven't had a second.
How many chunks of uranium have people sent you yet?
None. Nobody sent me uranium.
Send them uranium.
Please don't send me uranium. Of all the weird things to get in the mail, I don't want uranium.
Now we're getting uranium.
Although fun story time.
Send it to Fool Athens.
No, at one point I joked on Facebook saying I wanted a very small piece of uranium metal, just because as soon as you say you have uranium, people lose their minds. And somebody read it, and a group of people lost their minds and thought I was like building bombs. And I'm like, you're literally what's wrong with the world. Like you are literally why I made that joke. Promising cocktail to kill senescent cells. Yeah. FOXO4 DRI. It's a very neat drug. Very expensive. Now you've said it. People are gonna fricking send me uranium. I blame you for this, and I'm putting it on your desk. Just so you know.
You can send it to the lab. It'll be anonymized.
Oh my god. I don't have a PO box, so you can't send me anything. Ha. No, I might get a PO box at some point. The internet wants me to put uranium in your food, so I don't know. How bad do you want to be the Hulk, or
What?
get bowel cancer?
It's not a strong gamma source, though. Technically,
It's an alpha source.
It's an alpha source,
just
but
break
the
everything.
Hulk came from a gamma source, so
I have a Geiger counter. I don't need to buy one. It's really nice. It's digital. It's great.
one of our members built it.
I'm not answering that. Aoki, I'm not answering that. Do I code? No, I'm so bad at code. I'm an experimentalist. Like, I'm good at building things, not so good at the code. This is why I make friends with coders and buy them pizza and beer and so many energy drinks.
What's up with my bullshit?
What piece of lab equipment do you really want? Oh man. Laminar flow hood. I would love a new laminar flow hood. Like if I have one of those, I can get back into doing mammalian stuff, and that's just the best.
What's it on shop? Can we get it on Amazon?
How much pizza is on your desk? One slice. I've just been chewing on the same slice
I
this
handle
whole.
the same up here slice.
Yeah, I gave the other slice to Paul.
There actually is one on Amazon. BD650 vertical ventilation laminar flow hood vertical and clean bench workstation. Currently unavailable. Oh wait, no, here it is for $780.
Favorite tool? Is it a cop out to say a multi-tool?
My favorite tool.
Yeah, caliper.
Quality calipers.
Quality calipers is the way to go if I had to pick. Quality calipers and a bottle of Blue Dicom. Like maybe a hammer just for, when y'all in the comments are getting out of line. I already answered the favorite project. That's a hard question. I ended up going with the lactose thing because it was the one that literally changed my life. Okay, it's getting late. I think I'm gonna wrap this up. This has been a lot of fun. I would love to do another one of these probably when I hit the next 100K. Thank you guys so much for coming by, listening to the stream. Thank you for all the support on the channel. If you want to support the channel, the Patreon is always the best way to do that. Or check out the store. I think I make decent T-shirts and posters and stuff. So if that's a thing that you want, be sure to check that out. Other than that, there'll be a new video around Thursday, and yeah, that's kind of it. Thanks again for stopping by, and I will see you next week.